Today is 9/18/2022, and Annika helped wire our first together smart lights. Basically, you can control them with either Alexa or Google. And I think these are called Martin Jerry's model. So this is like a $10 version because there's no dimming. This is like a $15 version with dimming. And let's see if Anna can explain these wiring and with these colors. Go ahead, Annika. What do we do?
So basically,
you can come over here and point when you talk. Okay. This is Annika. She's 11, and I just explained her the concept of electricity.
So basically, we connected the wires. And
right now, this has electricity, okay?
Right now, it's electricity. I cannot touch it. If I do, I would die. Basically, can we go outside?
Go ahead. Just talk which color is carrying what.
So basically, there are 3 different wires from outside. But there's a 4th one coming from the ground. It's a metal rod sticking 8 feet under. And basically, it has no volts, no nothing. It's just a backup for the neutral. Yep. The neutral is the white one. And up there, outside, there are 3 wires. There's 2 volts, there's 2 of them with 120 volts, and there's another one with 0 volts. And basically, they're connected from a transformer, the 2 volts ones, and they come down and they go to the circuit breaker, or there's also a storm breaker,
a weatherhead,
and there's also a circuit breaker. The circuit breaker controls everything and blah blah blah. Basically, when it comes in, the ground and neutral are very similar, and the ground is a backup because if you get shocked, it'll go straight to the ground, and you have a 5% time you won't die, but there's like a 95% you will die. And basically, the ground, the live and the load have 120 volts in it, and the ground and the neutral do not have any volts in it. So live, the power will go into this thing, but it will stay in there until you say turn on, and this will load it into the lights.
Okay. So what's the difference between the black and the brown? Are they similar?
Yes.
Except black has power all the time, and the brown one only sometimes when you turn on the switch.
Yeah. On. See, look.
Okay. And see if it works.
On and off. Dim.
And it works. We haven't connected it to the smartphone in the house because
we're lazy.
No, because we have to do it by hitting this button. Then it gets into learning mode. If you hold on to this, it goes into a reset to learning mode, and when you turn it on, it will allow you to find it. All right, so hold this there real quick.
I farted on the moon.
So let's see if Annika can explain this concept. What's happening here, Annika? Why did we draw some pictures of trees and cars and
basically, everybody knows that opposites attracts. So basically, you know why we had the ground one and the neutral one? Because all the energy or lightning or anything wants to go to the ground. So if lightning hits you, it wants to go to the ground first and go all over your body and go be really high and die. Basically, if this is lightning and there's 10 feet up to the ground and there to from that.
What is 10 feet? For
10
example,
feet. Like the air.
The tree.
The tree.
The tree is 10 feet.
The tree is 10 feet.
It could be a 20-foot tree, but we drew a 10-foot tree.
Because we're lazy. Basically, would it want to go 10 feet, or would it want to go straight like 50 feet, or does it want to go down 10 feet and go to hit the ground first? It wants to go through the tree. If you're right next to the tree, it also wants to go through you and it would go down. But if it was closer, it would just go straight to the ground, or there's something attracting it. And if you're outside, there was nothing to block it to go to the ground, nothing to connect with an umbrella that's made out of metal, you will surely die because it's gonna go through it and you're gonna strike and die. Oof. But if there's a puddle of water and the lightning goes in the water and you touch the water, you will die. But if the ground, if it's right next to you, the wire, the lightning or the energy would want to go to the ground first instead of going through your whole body and having resistance. So it will go. So people are hoping for a safety measure. It will go down. It will go through the ground wire and go straight to the ground. So, but if the lightning hits the water and you're in a car, you want to be in the car because the car tires is connected by rubber. So it's the outside might be metal, but the inside is mostly plastic, rubber, and all that stuff. Cause over here the engine and all that stuff or something, I think that's a different thing.
That's a circuit breaker.
There was an engine. So this is the engine, and then there's rubber things.
The engine sits in a rubber mount.
And basically
And the seats that you're sitting on is also plastic.
Rubber and cow skin.
And the carpet
so
is
you're
also
basically
plastic.
safer in a car.
Okay. Now hold this paper. So let's say this is a 10 feet human being.
10 feet.
And next to it is a 10 feet ground rod. The question is, when the lightning hits, will it go through you, the 10 feet human being, or the 10 feet rod?
The 10 feet rod.
Because that is easier to go to ground. It's metal. It's 100% straight to ground.
It will not have any resistance because in a human body there are resistance.
There's like blood, salt, and like a whole bunch of stuff inside of us.
No one wants to.
The electricity is harder to go through us, even though we're 80% water.
My question is, to my dad that doesn't understand, how would I know what to go through?
Electricity is just like that. I can't explain it to you yet. This is another video. Okay.
Bye.
So now how about this video? Or this thing? What's happening here? Explain what are these.
Before that, I talked about the wire. This is basically the picture of it. So up there, you see the metal poles, right? There's 2 transformers, and then there's 3 strings.
By the way, transformers help carry electricity from long distance. It helps cool them down. It goes into, these are all a bunch of oil in here, and it cools it down.
Yeah.
Basically, it has to go through multiple transformers to get to your house. That's just all it is.
Basically, after it gets through, there's 2 wires with 120 volts. The one in the middle is white. It has nothing. It's neutral. It's basically the safety thing, like the ground. Basically, it will go down to the storm head, and go down to the circuit breaker and go into your house. But there's a 4th wire. It's from the ground. There's a rod that goes 8 feet under, and basically that's the thing. That's the safety thing from the lightning. Basically, all of those go in the house, and basically there's 4 wires, right? There's 0, 0, and 120, 120. The one on the ground this is the ground symbol universally, and they're normally green or copper. The one up here, the neutral one, is basically white, and then the rest is either blue or black. They will go in here, and basically so if you cancel this, there'll be no energy in this room. So basically we can touch the black one. But if you touch the black one here in the room, that's 120 volts through your body and you will die. Immediately.
Okay.
Well, not immediately.
So you want to explain people how to work the circuit breaker?
Isn't that on the roof?
No, the circuit breaker. Oh, sorry. This tool. Sorry. Step away from the chair.
My knees.
Okay. What is this tool? What's it called?
A multimeter.
Multimeter.
A multimeter that's digits.
So that means
it has numbers and it has multiple uses.
So so it's a digital multimeter.
Yeah, that's very precise because it has numbers instead of the one with the
analog.
Analog that has hands.
So multimeter, the word multi means multiple way. It's a meter that can do multiple things. And one of the things it can do is measure voltage.
So in the house, there's 2 voltage in the world, I guess. There is flat, straight voltage, and there's wiggly. In the house, we use the wiggly one.
Which is called alternator.
Alternating, where you go wiggly.
And this straight one's called direct.
Direct.
We use that for cars.
Yeah.
Cars have direct current. And
it's wiggly because we turn off and on, we go forward and backwards. Like
electricity goes in and out.
Yeah, that's how you remember the thing.
So what's up with? Why did I draw 120 and 0 and then 0 120? What is that with these things?
Basically, when the black one.
Hold the meter and tell what is it doing.
So when I said these have like the 120 and neutral. So basically, one of these hit I guess 120, right? And then it hits.
So you normally put the red to where the power is.
And the one that is not, and then if this one hits the white one or the no power, it would be 120 minus 0, which equals 120. But if this one goes to the white one with no power and this one goes to the power, it's 0 minus 120, which is negative 120, which means no power at all.
All right.
Logic. Okay, bye.
All right, that's it. Thanks for watching. Annika out.
No.